In this video, we will cover the basic math operators that are available in C++. There is plus, the hyphen, which represents minus, the asterisk, which represents multiplication, and a forward slash that does division. So plus, minus, multiplication, and division. These are common, very basic math operators that we can use. Here I've defined a variable called result, and I want to do some math, and I'm going to store that result in my variable called result. So if I do 14.7 plus 2.8, then I'm going to do the addition, store it in result, and let's go ahead and see out the result. And we'll just and type out result, put an NL. All right, let's see what the result of 14.7 plus 2.8 is, and it gives us 17.5, which is what we expect when we add those two numbers. If we put a hyphen in there, we get a minus sign, and we run that, and we get the result of 14.7 minus 2.8, which is 11.9. We can multiply these. If we take 14.7 times 2.8, what do we get? I'm not sure on this. This is something I can't do in my head, so let's go ahead and do it in the calculator. 14.7 times 2.8 to verify that we're getting what we expect, and sure enough, we get the result that we expect. Let's go ahead and do division by using that forward slash. And there we have 5.25. Again, let's test this with the calculator. 14.7 divided by 2.8 equals 5.25. So we're getting exactly what we expect from those mathematical operators. They're behaving as expected. It's not very common for us to use numbers here. What we more commonly see in coding is variables. So I'm going to put 14.7 in num1. I'm going to create a variable called num2 and put 2.8 in there. And then I use these as variables. So for my numerator, I'm going to put num1. For my denominator, I'm going to put num2. And now when I run it, I get exactly the same result using variables. Num1, whose current value is 14.7, num2, whose current value is 2.8, and I do that division and I get the same thing. Now, we can change the values of the numbers. Right? We can say, okay, do it with 20.1 and 3.0, and we run it again, and 20.1 divided by 3.0 gives us 6.7. We can test that. Divided by 3, and we get 6.7. So it works as we expected. Now let's try something different. Let's go ahead, and I want to introduce some integers. So I'm going to do int1, and I'm going to set it equal to 23, and int2, and set it equal to 4. And now I want to do some math with that. Now, plus, minus, subtract. Well, let's go ahead and do it. Let's say result equals int1 plus int2. And let's go ahead and see out the result. It's exactly this, so I'm going to copy and paste that line. And let's see what we get when we add those two together. All right, so I'm still getting my division up there, printing out the result. Then I do another computation, store it back in result, and this time when I print it out, I get 23 plus 4, which is 27. That's what I expect. I can do subtraction, and 23 minus 4 is 19, so we expect that. Let's go ahead and do multiplication. 23 times 4, which is 92. 23 times 4, that's 12 plus 2, 4, 8, 9, 92. So that's what we expect. Let's go ahead and do division. And we get 5, which is not exactly what we expected. Let's go ahead and do it on a calculator. 23 divided by 4, we expected 5.75 and we got 5. So here's where we see a significant difference in what we expect. And the reason why we're getting this is what is called integer division. Integer division is the kind of division that you did when you were in 3rd grade. So ways back to remember, right? But think about how you would have done this division way back then. You would have done 23 divided by 4, and you would have said 4 will go into 23 5 times, right? And then you do 5 times 4 is 20, and subtract, and you get a remainder of 3. So you'd have told your teacher the answer was 5 times with a remainder of 3. Notice how both those results, the 5 and the 3, are both integers. And that's what we call integer division. And C++ does integer division. So that's what it's doing here. It's giving us this result of 5, right? And so when we run this, it says 23 divided by 4 is 5. So it's giving the integer part of it. So up here we're getting real division, and here we're getting integer division. And the difference is when you get integer division whenever the numerator and the denominator are integers. All right, so if let's make the denominator num2, which is a 3. So if I take 23 divided by 3, what do I get? Oh, and I get 7.667. So here I have an integer divided by a real number, and in that case I'm going to get real division. And that's what we saw, is that we got a real number for the answer. Okay? So what happens is if you have a real number in the numerator or the denominator or both, you're going to get real division. But in the one case where you have an integer as the numerator and an integer as the denominator, you get integer division. Let's go ahead and try another number. So let's take and see if you can figure out what we're going to get. So if we take 19 and 3, what's going to be the answer? Remember, go back to 3rd grade. How many is 3 going to go into 19? Let's see if you're right. And sure enough, it was 6, like you expected. Let's take another example. Let's take 49 and divide it by 5. How many times will 5 go into 49? 9 times, right? So 5 will go into 49 5 times. There's going to be some remainder, right? Because 9 times 5 is 45. So that's going to be a remainder. Many times we want real division, and that's easy to get. We simply need to have a real number either as the numerator or the denominator or both, and we're going to get real division. But there are also times when it's really valuable to use integer division, and it helps us to solve some problems in a really straightforward, simple way. Let's go ahead and look at an example when this will come in handy. So look at this problem. You're going to take a bag of mini chocolate bars to camp. You're going to share them with the guys in your tent. There are 7 guys in the tent, and you have 100 chocolate bars. So how many can each person have if you want everyone to have the same amount? This is a good problem for integer division. Let's go ahead and create this problem here. So we're trying to figure out how many candy bars. So candy bars, when we're counting them, are always ints, right? We know that we have 100 bars. We know we have 7 scouts. Let me get that right. So I'm going to create a variable called scouts, and that there are 7 of them. And we want to know how many. This one we don't know, so I'm not going to give it an initial value, right? I know how many bars we have, and I know how many scouts we have. I don't know how many each boy is going to get. So I'm going to compute that. So I'm not going to give it an initial value. So I'm going to do how many, and I'm simply going to do the division. I'm going to take that I have this many bars, 100 bars, divided by however many scouts there are. And that's going to give me how many? And I can write out a solution here. Each scout gets all right, so let's see how this works. Let's see how many we get. Now, those of you who've been to camp before already have figured this out in your head, right? Each scout gets 14 bars. Okay, now, if we did that in a calculator and we did 100 divided by 14, what are we going to get? It says each scout gets 7.14285, and you know that that's not possible, right? There's no way to divide candy bars that way. So we're going to keep the candy bars whole, and we're going to give each scout 14 of those bars. Here's another problem that we could create. The girls' volleyball team is traveling to a regional conference. All 26 players are going. They are staying in dorms. Each dorm can hold 6 players. How many rooms will they need? So let's go ahead and do this problem. This sets us up with a new set of a new problem. If we're going to count players, right? We always have a whole number of players, so int is the right type. And we have 26 players. And we have in each room, how many beds in each room? There were 6 beds in each room. And how many rooms are we going to need? That one I don't know. That's the one I'm going to compute. So if I say rooms equals players divided by beds, you will need how many? You will need this many rooms. Okay, and let's see. Now, if you've ever been on a trip where you had to share rooms, let's see, you've probably done this in your head. All right, you will need 4 rooms. Is that right? No, because if you only have 4 rooms and there's 6 in each one, you're only going to have 24 places for people to sleep. So notice here, in the candy bars, it was okay because that left us with 2 candy bars left over. We could deal with that because everybody got the same amount. It's really easy just to consume those 2 candy bars and make it even. But now when it comes to rooms, it actually is a problem because it says that 6 will go into 26 4 times, right? But you have a remainder. This time we have a remainder of players. In fact, we're going to have 2 players left over, so we're going to need a whole another room. So this is a different problem. Integer division still gives us what we want because we can't have, you know, if we did real division and we had 26 divided by 6, we would get 4.333, and we can't have 0.333 of a room. So we really do want this many rooms, but we have to add 1 more to carry any of the leftovers. So this figures out how many we need, and then this adds a room for any that are left over. This will work in every case except when it divides evenly. So we really would need to say, well, if it divides evenly, don't add anything. If it doesn't divide evenly and there's some girls left over, then add 1. Making that kind of choice to sometimes add nothing and to sometimes add 1 is something that's more advanced than what we can do. So with what we know now, we're simply going to add 1 to the result, and this works in all cases except when it divides evenly, and now we know we will need 5 rooms. And that's exactly right. That's what you expected, right? That we would need 5 rooms to house 26 girls. Integer division is a good tool. It's a tool that we can use to solve some problems. But you need to be careful because sometimes it's not what you want. So always remember that these operators, the plus, the minus, the multiplication, all work the way you expect. Whenever you use division, you want to always make sure that you need to look at is it integer division or real division. And you need to make it the one that you want.